Right, grade 11s. Let's have a look at the stuff that we did in the previous lesson, and let's just briefly summarize this and then do an example. Okay, now what I'm going to do is I want you to look at this. The important thing to remember, and this is so important here, is that in the first quadrant, all three trig ratios are positive. In the second quadrant, sine is positive. In the third, tan is positive. And in the fourth, cos is positive. Okay, the rest are negative. Now, if we summarize that, if we go to another table, all are positive in the first quadrant. Sine is positive in the second, tan is positive in the third, and cos is positive in the fourth. Now, a way to remember this is all students take coffee. Okay, all, S for sine, TA for tan, and CO for coffee. So that's sine, tan, cos. All students take coffee, starting at quadrant 1. Okay, that'll help you to remember where sine is positive, tan is positive, and cos. And remember, in this quadrant 2, cos is negative and tan is negative. If you go back there, you can check it there. Cos is negative 10. Its sine is positive in 2. Tan is positive in 3 and cos is positive in 4. The rest are negative. The only quadrant where all three are positive is 1. Now, by the way, a way to remember these new ratios, I'll show you a lovely way you can remember this. Sine is y over r. So you could do it like this. You could say shade. Let me make that a little bit more clearer. If we go to, let's go to blue. Okay, listen to me carefully here. It's going to be shade your rear, okay, cos x rays tan your exterior. Okay, we can actually call that with a little x there. Okay, we call tan your exterior. Okay, if you remember like that. Now watch that. Sine is y over r. Sine is y over r. Look there. Shade your rear, cos x rays tan your exterior. Shade your rear, cos x over r tan y over x. Shade your rear. Remember sine. Shade your rear, cos x rays tan your exterior. Okay, you got it there, and that helps you. And then also, if you know that, then of course you also can see in quadrant 1 all are positive. Sine is positive. All students take for tan, coffee for cos, and you'll then remember. But remember, it's important, cos theta is negative and tan theta is negative in this quadrant. Okay, so this is very, very important here. Okay, now I'm going to show you an example of what we call a coordinates diagram. And how it works is, here's a little example. I'm going to say to you, if I'm going to give you sine theta is equal to 3, the fraction 3 over 5, and then I'm going to go naught is less than theta is less than 90 degrees, and you've got to then determine, without using a calculator and by means of a diagram, the value of cos squared theta minus 2 tan theta. Okay, no calculator, but by means of a diagram. Now, what we know is, if you look at this, we know something about sine. Now, I'm going to write this down very carefully. Sine is, as we know, a y over r. Shade your rear. Okay. Now, also, you probably agree with me that this number, 3 over 5, is positive. Okay, it's positive. Okay. Now, also, if you look at this restriction over here, this tells me from 0 to 90, I'm in quadrant 1. Okay. This tells me sine is positive. Now, in which quadrants would you be if sine is positive? Well, let's see. All students take coffee. So sine is positive in the first quadrant and the second. This is the first quadrant here. So if sine is positive in the first, and the second, but the restriction says you can only lie in the first, then logically your angle must lie in the first quadrant. Okay, so let's have a look at how we would then represent this. So to go through that again, you look at the fraction and you see it's positive in 1 and 2. The restriction tells you where the quadrants or quadrants that you may span across. In this case, it's from 0 to 90, which is quadrant 1. Okay, now how do we represent this on a diagram? Okay, let's have a look here. Now remember what I'm going to show you. We've got the sine of theta is equal to 3 over 5, which of course is y over r. Okay, now in other words, you're in the first quadrant because we also were restricted to that. Okay, we're restricted to where theta lies there. Okay, now if you're in quadrant 1, we don't know what the angle is, but we know it's some angle in quadrant 1. Okay, so let's draw a little angle here, what we call a terminal arm, if you like. That's the angle theta. It goes from there to there, and we've got the if we look at this, we don't know what the x is, but we know that the y is 3 and the radius of the circle going around there is 5, because remember sine is y over r. Okay, and if we just draw a little triangle down here and make it right angled, well, what is the vertical side? Is going to be 3 for the y. The x, we don't quite know what its length is. It's this one here. Okay, the radius is 5, which is great. Now, what we now need to do is we need to get that unknown x. And, of course, you probably realize that Pythagoras will come in handy here, because it's a right angle triangle. X squared plus the y squared is equal to the radius squared. Okay, which, of course, is x squared plus 9 is 25. So x squared is going to be 16 if you bring that across. Now remember from quadratic equations in earlier years, you would go plus minus the square root of 16, which is 4. But if you look at the diagram, and I think this is important, x can only be 4. Alright, because it's in the first quadrant where x is positive and y is positive. So therefore we say x is equal to positive 4. So you know that your x is 4, your y is equal to 3, and your radius is 5. And that information is going to be of utmost value when we try to answer this question here. Okay, where is it here? Here we go. Okay. It's going to be when you answer this thing here. Now, notice, it said it gave you this trig equation. We know that that's y over r. We then found x from Pythagoras, but we located our quadrant. We're between 0 to 90. We're in quadrant 1. Sine is positive in that quadrant, but even though sine is positive in the second, because of this restriction, we were restricted in 1. Okay, and then what we then said is, okay, great. If you're in quadrant 1, we've got the radius, because sine is shade your rear, which is y over r. That's your y, and in your x you use Pythagoras, you get your triangle, and x is equal to 4. Now, the rest is easy, because if you want to work out cos squared theta minus 2 tan theta, look at this. Okay, so it's cos squared, and I'm going to use a slightly darker color here, which will be better. There we go. Okay, so if we look at that, we can say, well, what is cos squared theta? And then we're going to have to do minus 2 multiplied by tan theta. Well, this is easy because you already know what these are. This is going to be something squared minus 2 times a fraction. Cos shade your rear, cos x raised tan your exterior. Now, come on. What is the x? The x here is, we worked it out as 4. And the r is 5. So there we go. It's 4 over 5 squared minus 2. The y value is 3 over the x, which is 4. So it's 3 over 4. Okay. So it's 3 over 4. Okay, and then all you now need to do is use your calculator or whatever to work this out. If you don't even need your calculator for this one, 16 over 25 squared, that's 6 over 4, which is, or 2 goes into 4 twice, so it's 3 over 2. And then all you then need to do is get the lowest common denominator, which is 50 in this case. And if we do that, pretty much basic fractions there, and then times 25 times 25, and then off we go. And then you just use your normal school maths there. Okay, so that gives you 32 minus 75 all over 50. And if you work that out, that comes to negative 43 over 50. And there we have it.